This lesson is the fourth of a series of lessons in Algebra 2 titled Lesson 1.2.2 Properties of Exponents Part 2. As always, while students are entering the classroom, show this slide on screen. The teacher is advised to meet the students at the door and hand in to each student a copy of the bell ringer. When the bell rings, click this slide, which reminds students that they have 5 minutes to complete the bell ringer. While students are doing the bell ringer, the teacher will check their attendance, then distribute the classwork sheets. At the end of the 5-minute period, discuss with students' participation the bell ringer. This is lesson 1.2.2, Properties of Integer Exponents Part 2. By the end of the period, with at least 80% mastery, students will be able to define integer exponents and powers, and apply the rules or properties of exponents. We recall that a to the n means a times a times a times a and so on times a n times, where a to the n is the nth power or exponential expression. A is the base and n is the exponent. Now let's go to B, division properties of exponents. You have number 1, quotient of powers property. A to the n divided by a to the n equals a to the m minus n, provided that a is not equal to 0. So, in words, this means to divide powers having the same base, keep the base and subtract the exponents. Example number 1. Simplify. Letter A, 6 to the 4 divided by 6 to the 1. So this is 6 to the 4 minus 1 equals 6 to the 3. 7 to the 8 divided by 7 to the 5 equals 7 to the 8 minus 5 equals 7 to the 3. Letter C, m to the 6 divided by m to the 11 equals m to the 6 minus 11 equals m to the negative 5. Letter D, negative 2 to the 8 divided by negative 2 to the 4 equals quantity negative 2 raised to 8 minus 4 equals negative 2 to the 4. Number 2, the power of a quotient property. Quantity a over b raised to n equals a to the n divided by b to the n as long as b is not equal to 0. In other words, to raise a quotient to a power, raise both the numerator and the denominator to the power. Example number 2. Simplify. 1/2 raised to 6. This is equal to 1 to the 6 divided by 2 to the 6 is equal to 1 over 64, because 1 times 1 times 1 times 1 6 times is just equal to 1. And 2 to the 6 means 2 times 2 times 2, 6 times is 64. Letter B. 3/5 raised to 4 equals 3 to the 4 divided by 5 to the 4 is 81 over 625. Letter C, 5 over m raised to 3 equals 5 to the 3 over m to the 3 equals 125 divided by m to the 3. Letter D, 3 over b raised to 4 equals 3 to the 4 divided by b to the 4 is 81 over b to the 4. Number 3, zero exponent. A to the 0 equals 1 as long as a is not 0. In words, any base raised to the power 0 is 1 as long as the base is not 0. Example 3, simplify. Letter A, negative 3 to the 9 divided by negative 3 to the 9 equals negative 3 to the 9 minus 9 is negative 3 to the 0 or 1. Letter B, 8 to the 3 times 8 to the 2 divided by 8 to the 5 is 8 to the 3 plus 2 divided by 8 to the 5 equals 8 to the 5 divided by 8 to the 5 or 8 to the 0, which is equal to 1. Negative exponent. A to the negative n equals 1 over a to the n, and 1 over a to the negative n equals a to the n, where a is not 0. Simplify. Example number 4. Simplify. 6 to the minus 5. This can also be written as 1 over 6 to the 5. Letter B. 1 over 7 to the minus 6 can also be written as 7 to the 6. Letter C. M to the 6 divided by m to the 11. Using the property of division of fractions and exponents, this can be written as m to the 6 minus 11 equals m to the minus 5. And writing this having a positive power is 1 over m to the 5. Letter D. Negative 2 to the 3 divided by negative 2 to the 6 is negative 2 raised to 3 minus 6, which is equal to negative 2 to the negative 3 or 1 over negative 2 to the 3, which is 1 over negative 8. Letter E. A to the 9 over a to the 5 raised to negative 1 is a to the 9 minus 5 raised to the negative 1, or this is equal to a to the 4 raised to the negative 1 equals a to the negative 4. And this is also equal to 1 over a to the 4. Letter F. Y to the 2 divided by y to the 3 raised to negative 2 is y to the 2 minus 3 raised to negative 2 is y to negative 1 raised to negative 2 equals y squared. In other words, negative 1 times negative 2 equals positive 2. If there are no more questions, then let the students complete the classwork until the end of the period.